Okay, ladies and gents, hopefully a bit of revision for you, and it's to do with areas. Okay, what is an area? Area is a term used to define the amount of space taken up by a 2D shape or a surface. Hopefully that's self-explanatory. Okay, what is the area of this board? Okay, it's the area that the space that board has taken up on the wall. That's quite a big space. The space that's taken up by the attachment for the overhead projector there is quite a small space. Okay, so area, the amount of space taken up by an object. Units, really important that you've got a grip of units. So what are the general units that we use for area? We could have centimetres squared, we could have metres squared, we could have millimetres squared, we could actually have kilometres squared. We're talking about the area of a site, you know, the site of a hospital. It might be measured in kilometres squared. Okay, so they're areas, they're measures of area. Okay, and that squared is very important to make sure you get that in there and you understand what your measurements are going to be applied. Okay, right. So really simple stuff. A square, the area is the base times the height, and the base and the height of a square are going to be what? They're going to be the same, aren't they? So if you had a square that was 3 centimetres each side, its area is going to be 3 centimetres by 3 centimetres, so its area is going to be 3 times 3, which is 9 centimetres squared. Okay? It's a square. A rectangle, very similar. Base times the height will give you the area. So if we had a rectangle that was 4 centimetres by 2 centimetres, our area would be 4 times 2, which would be 8 centimetres squared. Very important you get those units correct. Okay? Quite often you will get a mark in an exam for getting those units correct. So make sure you've got that in your head. Right, triangles. Triangles. We've got a height, we've got a base length, and our area is half times the base times the height. Some people remember it as the base times the height all divided by 2, but they are both the same. Half times base times height, or the base times height divided by 2, comes out as the same result. And it's very important that you catch hold of this vertical height, and I'll talk about that in a minute. But if we had base times height, so let's give ourselves a height of 4 centimetres, a base of 3 centimetres, a half times base times height, so a half times 3 times 4 would give us 6 centimetres squared. And similarly, if we had base times height, so 3 times 4 all divided by 2, it's still going to give us 6 centimetres squared. It's very important we go back to this. It's the second time I've mentioned it. It's the vertical height. So if we get an example, we haven't got a right angled triangle, so obviously a right angled triangle. We've got to be thinking about, okay, well, there's a base, maybe that's 8 centimetres. Vertical height. Vertical height, so that could be 3 centimetres there. So our area is half times the base times the vertical height. So half of 8 times 3, 12 centimetres squared. 12 centimetres squared. It's really important that you get that idea of it's the vertical height. Okay, now we might get something like this, which isn't so obvious. They might present us with something like that. It's quite a common examiner's testing you out, let's say. So we've got 3 centimetres along this length, and they're giving you that that is 9 centimetres. Okay? So what we've got there, we've got a base of 3 centimetres, we've got a vertical height of 9 centimetres. Is that what we're looking for? Yeah, that's what we're looking for. So our area is going to be a half times 3 times 9. So 3 times 9 is 27, and a half of that is going to be 13.5 centimetres squared. Okay? Idea of vertical height, very important to latch onto that. Okay, parallelogram. Again, this idea of vertical height comes in. A parallelogram, make sure you understand what that means. A pair of parallel sides there, indicated by those little arrows. A pair of parallel sides here, indicated by the arrows. Okay? A base length and a vertical height. It's very important that it's a vertical height. Don't get caught when an examiner gives you a sloping height. Look for a vertical height. That's what we're trying to apply in our formula, and the area is then going to be the base times the vertical height. So very simply, if we had a base of 5 centimetres, we had a vertical height of 2 centimetres, it would be 5 times 2 equals 10 centimetres squared. Okay? Vertical height, that's the important factor there. Okay, trapezium. Trapezium only has one pair of parallel sides. Parallelogram, that's 2 pairs of parallel sides. The trapezium only has one pair of parallel sides. And that's really important, because it's those parallel sides, it's the lengths of those parallel sides that go into our formula. So traditionally in the textbooks, those parallel sides are labelled A and B. Our vertical height, again, vertical height is H, and our formula gives us half multiplied by A and B added together, multiplied by the vertical height. So that's our formula, where A and B are the parallel sides, and H is the vertical height. I'm saying that several times now. A and B must be the parallel sides added together, and H must be the vertical height. Area equals a half times A plus B times the vertical height. Okay, so that's the formula for the area of the trapezium. So if we had the vertical height 3, A was 2, B is 4, if we plug that into our formula, we get a half multiplied by what's A plus B, so it's 4 plus 2, and then multiplied by the vertical height, so we have a half times 6 times 3, so all that comes out as 9 centimetres squared. Okay, half times A plus B times H. A and B are the parallel sides, H is the vertical height. So the only thing that I want to sort of remind you of now is this idea of a compound shape. We haven't got a formula to calculate the area of that shape straight away. We haven't got a formula to calculate the area of that shape straight away. However, what we can do is, if we've got enough information about the dimensions, if we're given enough information about the various lengths, what can we do? We can split this shape into what we've got here. We've got a rectangle and we've got a triangle. Do you know how to find the area of a rectangle? Yeah, you do. Do you know how to find the area of a triangle? Yes, you do. So if you had enough information given to you by the examiner, could you actually find the area of that shape? Yes, you could. Find the area of the rectangle, find the area of the triangle, add them together, and you get the area of the total shape. Similarly, what have we got here? We've got an L shape, and we've got a formula to find the area of an L shape. No, we haven't, but what we could do is we could divide it into two rectangles. It doesn't matter whether you have them divided like that or divided like that, depending on the information that's given to you by the examiner. Could you find the area of one rectangle, the area of the other rectangle, add them together and find the area of the L shape? Yeah, you can, okay? And it's how you do that with the information that you're given by the examiner. So, in this L shape, for example, the examiner might give you that's 5 centimetres, 2 centimetres there, so that's 6 centimetres. That's not very neat, is it? So let's go back. 6 centimetres. Like that, 2 centimetres. So they might give you those pieces of information. Can we now work out the area of that whole shape with that information? Yeah, do you know what, we can. Right, we could do it like this. We could say, right, we're going to put in a dividing line there. So we've got a rectangle here, we've got a rectangle here. What's the area of this rectangle? 6 times 2 equals 12 centimetres, because we've got a height of 2 there, we've got a base of 6. Now, we know that's 2 centimetres. We don't know what this length here is straight away, but we do know that all the way down the shape is 5, and this part is 2 centimetres, so that means that's 3 centimetres. So the area of that rectangle is going to be 3 times 2, so that's 6. So now we've got the area of each of the rectangles, 6 centimetres squared for the top bit, 12 centimetres squared for the bottom bit. So the whole area equals 6 plus 12 equals 18 centimetres squared. Okay? So look at the information the examiner's given you. Can you break it down into a couple of shapes that you can deal with? Yes, we can. Can you find the area of each of the separate shapes? Yes, we can. We've done it. Find the area of the two separate shapes and then put them together. Okay? So compound shapes. Could we deal with something like that? Yeah, of course we can. What's that? Effectively, it's 3 different rectangles. So we could split that into rectangles. We could split rectangles there, depending on the information that we've been given. We could split rectangles there, depending on the information that we've been given. We could even do that, depending on the information that we've been given by the examiner. Just break it up into shapes that you can deal with. Yes, we can deal with rectangles. No, we can't deal with that sort of U-shape, horseshoe shape. So it's just about taking a compound shape, breaking it down into shapes that we can deal with. Okay, that's been a quick revision of angles. Areas of squares, areas of rectangles, areas of parallelograms, areas of trapeziums, and then talking about compound shapes. Breaking a shape down into areas of shapes that we can deal with. Okay? Hopefully that's been useful to you. Hopefully that's been a good reminder. Thank you for your concentration and attention. Thank you.